Hi, today we're going to be looking at functions and mapping and when maps can be functions and when they can't be. There is about to be a little graphic come up on the screen. Have a look at that, copy it down, think about it, and then we'll be ready to move on. Right, now the important thing is we can have a function that maps from one thing to one thing, so when you ask it one question you get one result, or you can have it that goes from many things to one thing, so you're still asking a question, you're getting one result, but what you can't have is to ask it one thing and to give many solutions. So this one here, you're going from one and it's giving you more than one, so that is one to many, and that means it's not a function. Okay, so that's A, not a function. B, every value of x is going to give you one value of y, so that is 1 to 1. And you can have a function of that, y equals 2x plus 5, you can write as, and that's absolutely fine. Coming to the next one, every value of x does have one value of y, but what we do have here, sorry, that was a function, but this here is not a function because we have an asymptote. We've actually got two, but we've got one that's important for when we're having our values of x. The questions we're asking it, it's not giving us anything, therefore it's not a function unless x equals 0 is ruled out of the domain, is not in the domain. So what does that look like? Because we're going to be thinking about a domain quite a lot today, and the domain is all the values that you're saying are valid and are part of this whole thing. So we could write this as a function if we said, right, okay, so we want 1 over x where x is all real numbers and x does not equal 0. So that's an important point. So just on its own, y equals 1 over x is not a function. You have to rule out x equals 0. And this last one here, well, we've had one to many, we've had one to one, so no surprises that this is going to be many to one. Many to one because we've got two values that are giving us an answer. But if we ask it a question with plus x, we're getting that y value. If we ask it with the negative x, we're still getting that y value. So we can have the same answer, and that's justifiable and could be useful. So that's okay. That is a function. Right, now we're just going to have a look at a couple of examples and then you'll be on your way. Copy this down and have a little think of it. Find the range of the function 3x minus 2. The domain is x is 1, 2, 3, or 4. And when I first saw one of these, I thought that the range was going to be, well, if x is 4, I'm going to get 12 minus 2 is 10. If x is 1, I'm going to get 3 minus 2 is 1. So 10 minus 1 would be 9. But that's actually not the range. That's the range of a set of numbers when you look at it. But what we actually want when we're given set values of x, which are the only ones that can be, the range needs to be all of those values. So when x is 1, we're going to get 3 minus 2, which is 1. when x is 2, we're going to get 3 2's are 6 minus 2, which is 4. When x is 3, we're going to get 3 3's are 9, take 2 is 7. And when x is 4, we're going to get 4 3's are 12, take 2 is 10. So the range is going to be, and we list those in the same way as the values of x were in the first place, 1, 4, 7 and 10, because they're the only possible answers you could get. You can't get 8 or 9, you can't get 5 or 6, you can only get those specific numbers. So the next one is looking at the range of the function x squared, and it's just between -5 and 5. Now this time it hasn't given you a list of values, so we are going to have a total range of things, but we still need to know where it's going from and where to. So just to think about it, let's pop in a little sketch of y equals x squared to get that function going, and it's going to be a curve, isn't it, doing something like that. And when x is 5, -5, that's going to be giving us 25, isn't it? Because -5 squared is 25, 5 squared is 25. Sorry for the shoddy sketch, but you get the idea. Hopefully we're getting those same answer there. The smallest possible answer that we're getting is 0, so the range of f of x is going to be, and we can use inequalities to do this, from 0, bigger than or smaller than, up to 25, and it's the function of x that we're popping in there because it's like our y value on the graph. Right, one more of these ones. This time the function f is 1 over x, and notice that the range of values we're asking for is bigger than 0. That is because this is the same graph we were thinking about before, isn't it, where 0 can't actually give you anything because it's an asymptote of the graph. So if I just sketch this in here, you would normally be thinking, right, well, 1 over x is giving us something like this, isn't it? And we're thinking but from 0 to x, so we are going from bigger than 0 to 3. So we are just bothered about it from there to there. What are our values of y going to be? So first thing to do is think, right, well, when x is 3, so if x is 3, we get 1/3, don't we? And what else is happening? Well, it's just getting bigger and bigger and bigger. So therefore, all we need to say is that the function of x is always going to be bigger than or equal to 1/3. And before we move on, I just want you to think about the fact that what sort of mapping have we got here? We've got one which is 1 to 1, haven't we? So that would be 1 to 1. You may be asked this. So let's have a little look back at the one before. What's this? This is, well, those two both giving us the same one means that that one is many to 1. And the very first one, well, each solution only had a one possibility thing there, didn't it? So these are all, that is a 1 to 1 as well. Right, for our final example today, we are looking at something a little bit different. Have a look at it, see if you think what's going on. It's what I'd call a complex function, because you've got more than one thing going on. In the range x is smaller than 1, it obeys this rule. In the range x is bigger than or equal to 1, it obeys this one. And this, normally, if the range was going over all values for x, would be a many to 1, wouldn't it? So what's going to happen this time? Whereas this is a 1 to 1, what's going to happen this time? Well, the first thing to do, to think about what's going on, is to sketch it. And in fact, I'm going to pop 2 questions down here for what we're going to do. So yeah, the first thing to do is to sketch it. And the reason we want to sketch it is because we want to be able to sort of state the range of what's going on, and it makes it much clearer if we do. So we're going to be sketching both these things sort of separately. So let's start off with the simpler one, which is the straight line 5 minus 2x. Well, we know that that would be going through 1, 2, 3, 4, 5. And that its gradient is -2, so across 1 down 2, across 1 down 2, across 1 down 2. But we also know, and continue that up there and there, we also know that that's only relevant when our x value is less than 1. So we don't want to be drawing it beyond there. So if I pop that in there, that bit we want. And then if we had x squared plus 3, well, x squared plus 3 is going to, would be, if I just do this with pencil first of all, if it was x squared, it would be down there, wouldn't it? So if we add 3 to there, so 1 squared is 1 plus 3 is 4, so that's going to give us a value there. 2 squared is 4 plus 3 is 7, so that would go there. When it's 3, 9 plus that's going to have gone off there, and then it's going to, it would be a mirror image over there, but we're not bothered about when it's smaller than 1. We are just bothered about when it's more than 1. I don't want that little bit in there, do I? Just before it gets to there. So what we are finishing up with is something which is jumping. And if you remember when we've done representing things on a number line, when it is actually equal to something, we have a filled in dot, don't we? So we can represent that in that same way there. But when it is not equal, when it's just less than or more than, then we have a circle. So we can, an empty circle. So that shows that when x is 1, this is our relevant result. So we only have 1. So then this is actually 1 to 1, isn't it? It's not asked us about that, but it is. It's 1 to 1. So let's just jot that down. Now, what is the range? The range, well, it can never be less than 3, but can it be any value more than that? Well, as these continue on going, it's just going to grow and grow, isn't it? So it is going to be just anything that's bigger than 3, and it is bigger, not equal to 3, because remember that at that point there, when it gets to 3, that's when it jumps across to here. So we can say that the range of f of x is bigger than 3. We're not quite done yet though, because there's actually a second part to this question, which is solve function of x equals 19. So we're saying, right, when our value is going to be 19, what could we have? And we're going to have 1 of here and 1 of there as well. So let's do the straight line first, because that's the simplest one. So we've got 5 minus 2x equals 19. Well, I could add 2x to both sides, couldn't I? And I could take 19 at the same time. So that would give me 2x over here. Take 19 away from 5 gives me negative 14. I can then divide by 2 and I get negative 7 equaling x. Okay, so x could be negative 7, but also what happens if I've got my x squared plus 3 equaling 19? Well, I could take 3 from both sides, leaving me with a very nice x squared equals 16. I say nice because it's a square number. So x could be, now normally we would say plus or minus 16. I'm going to write down 16 or negative 16 for a good reason, and then think about it. Can I get a negative, sorry, not 16, 4, isn't it? Or negative 4. When x is negative 4, we're using the other rule, so that cannot be. So in this instance, we do not want the positive one. If the conditions had been the other way around, it could have been that this was over, the curve was the one dealing with the negative. So that's why it's always important to draw a sketch so you can visualize which one you're going to need. So at the end, you just say, yeah, your solutions are x equals 4 and x equals negative 7. Right, time for a little bit of practice. Right, so in terms of practice on page 30, exercise 2b, questions 1 and 2, just sort of getting you into it and thinking about it, worth doing. But if you're really confident and you want to just have a crack at the exam style ones, by all means go straight on to 8, 9 and 12. And as ever, I will put these the questions and answers will go on the video following this right now. Okay, see you tomorrow.